Now we're going to look at inter-VLAN routing, which we call a router on a stick, and a layer 3 switches. Now the problem is that departments need to communicate, and so far those departments, they cannot communicate. Okay, so last time what we did, we had a perfect VLAN isolation, which is just working perfectly. Finance on 10.10.1, it was 0/24 network, HR on 10.10.2.0 slash 24 network, and then IT on 10.10.3. So they are completely isolated. But then the finance manager says they phone IT support and says, I need to access the HR payroll file on server 10.10.2.50 to verify the month-end figures. Why can't I reach it? All right. So a network engineer answers, it's because you are in VLAN 10, right? And HR server is on VLAN 20. So those are separate broadcast domains. So you need to cross a layer 3 boundary, a router, just to get there. So the finance manager says, okay, it's fine, make it work, but make sure that IT can still monitor both. And that is the inter-VLAN routing that we're talking about. Here's the thing why layer 2 cannot connect to VLAN, which is the ARP problem. When finance PC1, which is 10.10.1.10, tries to reach HR PC1 10.10.2.10, the first thing it does is to check, is it on the 10.10.2.10? Is it in the same subnet? No, it's not in the same. All right. So it's on 10.10.1.0/24, not on 10.10.2.0/24. So finance PC1 sends the packets to its default gateway, which is 10.10.1.1. Now to send to the gateway, finance PC1 first does an ARP broadcast, who has 10.10.1.1, and then tell 10.10.1.10. So that is ARP broadcast is tagged VLAN 10. All right, so it stays in VLAN 10. So the switch never forwards it to VLAN 20. So if the router's sub interface, say G0/0.10 is not configured and listening to VLAN 10, then the RP just goes unanswered. Right, so finance PC1 never gets the gateway its MAC address, and then the IP packets never leaves the finance PC1. All right, so inter-VLAN routing at layer 3 is, specifically a router on multi-layer or a multi-layer switch, is the only solution. So the router is the answer, and then we're going to configure our router here. So our existing Elpda Solutions Johannesburg router in two ways. First, router on the stick using sub interfaces. Then I will show you the enterprise method, a layer 3 switch with SVIs. Router on the stick, it's one physical cable from the router to the switch. One cable carries all 3 VLANs simultaneously. Right, so because the switch port is a trunk, and then tagging every frame with its own VLAN ID. So on the router side, we create sub interfaces. So a sub interface is a virtual logical division of one of the physical interfaces. So for example, G0/0 will handle, or /0.10 handles VLAN 10 frames, and then it reads the .1Q tag, which is 10, and then processes them, and then G0/0.20 handles the VLAN 20, and then G0/0.30 handles the VLAN 30. So each sub interface has its own IP address, which becomes the default gateway for the VLAN. Is that the physical interface must be up, so no shutdown, but it must have no IP address, and then the IP addresses live only on sub interfaces. So think of the G0/0 as a pipe, and the sub interface as the taps coming off that. The second method is what the enterprise world actually uses. Instead of the external router, a layer 3 multi-layer switch. So maybe that is a 3560 All right, but we will just see which one we can actually use. So, but it does the routing internally in a hardware. An SVI, or a switch virtual interface, is a virtual layer 3 interface on a VLAN created directly inside a switch. All right. So interface VLAN 10 with IP address 10.10.1.1 becomes a gateway for all VLAN 10 devices, and then just routing between SVI happens in the dedicated ACIC chips inside the switch at a wire speed, with no traffic ever leaving the box. Let's go ahead and do method 1, which is router on the stick on the router. So we're gonna go ahead and go to our Johannesburg router. Let me just bring the window, and then we'll just go to the CLI. All right, now we're gonna configure first enable, and then we're gonna configure terminal. Then we need to remove the old IP from G0/0. Guys, when I'm talking about G0/0, I'm talking about gigabit Ethernet. So we're going to say interface, gigabit Ethernet 0/0. All right, and then we're going to say no IP address. So we are removing the IP address from that, and then no shutdown, and then exit. So we just removed the IP address. And then step 2, we need to create a sub interface for a VLAN 10, which is VLAN 10 is finance 10.10.1.0/24. All right, so we're going to say interface gigabit Ethernet 0/0, and then .10. All right, and then we say encapsulation .q 10. I think I got a spelling wrong. Encapsulation .q10. Oh, it's actually .1q. Sorry, I was like missing that. Yeah, so it's .1q. Okay, there we go. And then we need to give it an IP address, which is 10.10.1.1, and then the subnet is 255.255.0. 255.0. And then exit. All right, and then step 3 is to create a sub interface for VLAN 20, which is HR on 10.10.2.0/24. Interface gigabit Ethernet 0/0.20. and then encapsulation dot 1q 20, and then IP address, which is 10.10.2.1, and then the subnet 255.255.255.0, and then exit. And then step 4, we need to create a sub interface for VLAN 30, which is IT. So IT is on 10.10.3.0/24. And then we need to fix the this one. All right, and then we can exit. All right, and then we need to do interface dot 30. And then encapsulation so here encapsulation is 1q.1q30, and then we can just give it an IP address, IP of 10.10.3.1, and then subnet is 255.255.255.0, and then exit, and then end. All right, so let me just walk you through each and every command that we've done carefully. So the first thing that we did, no IP address on G0/0. So this removes the old 10.10.1.1 address that was that we set before. So the physical interface stays up, no shutdown, just keeps it active, but it no longer has its own IP. So it's just a physical pipe. Now, and then interface gigabit Ethernet 0/0.10. This creates a sub interface 10. So then the number after the dot can be anything really, but we match it to the VLAN number for clarity. Now the router sees this as a completely independent virtual interface, and then encapsulation dot 1q10. So this is critical because this command tells the router any Ethernet frame arriving at G0/0 with a VLAN tag 10 belongs to this sub interface, and when this sub interface sends the frame out, tag it with a VLAN 10. So this is a command that binds the sub interface to the specific VLAN. Without it, then the sub interface receives nothing. And then IP address 10.10.1.1, 255.255.255.0. This is the same gateway address that the finance PCs were already configured previously, right? So we have not changed a single IP address on any PC. So we just change where on the router that IP address lives. So it moves from G0/0 to G0/0.10. All right, so it's the same thing with HR gateway and the IT gateway as well. Now we actually need to verify the router's configuration, so we'll just say show IP interface brief, and guess what, here they are. You see those? So here they are. So all of them are up. So we can also show the routing table by running show IP route. Then you can actually see, look, the routing table, especially the VLANs. It shows up with no, with no IP for G0/0. Then G0/0.10 shows up with an IP of 10.10.1.1. You see that? So the connected route, which is 10.10.1.0/24, 10.10.2.0/24, 10.10.3.0/24, and then we still have the WAN routes, that we did before, which is 10.10.100.0/30, and then the 10.10.101/30. They are still there. They are unchanged. If you look at the routing table, there's 3 new connected routes, 1 per VLAN subnet, and our WAN routes from previously are still intact. So the serial interface are untouched, and then we have added Inter-VLAN routing without breaking the existing WAN connection or configuration. So that is clean, and it's just additive network engineering, really. Let me give you a scenario. Say maybe let's take Absa Bank, Johannesburg branch network. Maybe they added a VLAN segmentation to their existing WAN infrastructure using exactly this approach. So router on the stick sub interface is added to the branch routers without modifying, the MPLS WAN links. So the VLSM WAN subnets, the /30 links, and the VLAN LAN subnets coexist on the same routing table. So this is why keeping a consistent and a well-documented address scheme like our 10.10.something.0 plan is so important. It's very important. All right, let's go ahead and test. Let me just save, and then so that we can test. So I'm gonna go to, let's take finance PC1, which is on .1.10, and then we're gonna ping HR, which is .2.11 or .2.10. All right, so we're gonna ping HR .2.10. Okay, let's go ahead and test this, and then we're gonna ping 10.10.2.10. There they reply. Okay, remember the first time out is just trying to figure out what's going on, but there we go. So now if we run it again, then there you go. So now that means finance can communicate with HR. Okay, so it's just 4 successful replies from 10.10.2.10. So it's 4 out of 4. Finance PC1 just reached HR PC1. So let me trace exactly what happened in the ping step by step so that you can visualize every time. So step 1, finance PC1, which is 10.10.1.10, checks is 10.10.2.10 in my subnet of 10.10.1.0/24. No. So it sends the packets to its own default gateway, which is 10.10.1. And then step 2, finance PC1 does an ARP for 10.10.1.1, and then the switch, which is switch 1 in our case, forwards it within VLAN 10, and then the router sub interface G0/0.10 responds with its MAC address. And then step 3, finance PC1 builds an Ethernet frame, and then which is a source MAC, which is equals to finance PC1, and then the destination MAC, which is router G0/0.10, and then the switch tags it VLAN 10 and sends it towards G0/2, so it's trunk to router. And then step 4, the router receives the frame from G0/0. It reads the .1Q tag, and then a V, which is VLAN 10, and then the router to sub interface G0/0.10. It just strips the Ethernet frame, reads the IP packet, and then to the destination, which is 10.10.2.10. And then step 5, the router checks the routing table, which is 10.10.2.0/24 is directly connected to what? To G0/0.20. And then the router builds a new Ethernet frame, which is just a MAC of the MAC address. The source MAC will be G0/0.20 MAC, and then a destination MAC will be HRPC1 MAC, and then it tags it with VLAN 20. It sends out the G0/0 as a trunk frame. And then step 6, the switch, our switch received the VLAN 20 frame on G0/2, and then it looks up the HRPC1 MAC in VLAN 20, and then it forwards it to the port, to the port 3. Remember, we connected it on port 3, right? So it forwards it to the port 3, which is HRPC1 access port on the switch. All right, and then it strips the VLAN tag before delivery. And then the last step, which is step 7, HRPC1 receives the packet. Then the round trip reply just follows the same path in reverse, basically. Now let's ping IT. Let's see if we can ping IT. So we can ping 10.10.3.10, which is IP, which is IT. There is a reply from IT, so we must just repeat it 2 times because the first one, it's actually lost. And then we can see now, we can see a IT as well from HR, from finance. So it works. All 3 VLANs, 10.10.1, and then 10.10.2, and then 10.10.3 are now fully routable through our Johannesburg router. And finally, we can still ping the Cape Town router and see if the WAN still works as well. So we can ping 10.10.100.2, and then we get a reply from Cape Town. So the WAN links are completely intact. So the router at Johannesburg is now routing 3 things simultaneously: inter-VLAN routing between finance, HR, and IT, and then the WAN link to Cape Town, and then the WAN link to Durban. One router doing it all.